In my third offering, I'll look at managing hardware, some of the electronics I selected, and assembling the steering and part of the shock system. These are some tools that I've used that were really good. The portable cordless drill that has variable speeds, good for screws as well as for drilling. Dremel tool, that's probably a luxury. The deburring tool in the middle is really useful, especially if you have brim around parts. It's basically got a series of knife edges that are replaceable, and you can easily trim off the brim with that. All my hardware parts pretty well came from AliExpress, because in Canada it's really expensive to buy small amounts of parts. I found AliExpress very good to deal with. The only downside is it takes from 2 to 8 weeks to get orders, and often if you have a small order, say $10, it's held and combined with others, so that may add a week or two. I only had one order that was lost, and several orders I've made. It came in 5 months, but I got a refund for that order within, I think, about 8 weeks. You can also use a messaging feature in AliExpress to contact individual stores, and I've made a couple requests which were handled really easily. I changed the color of a shock that I wanted. I also had a 6mm belt that I asked if they would cut to 4mm, which was no issue. There is a Canadian company, rcprinter.com. If you don't want to buy parts online, they supply kits. They don't supply a kit of parts for Badger, but they have all the hardware, the M3, M2 screws, and other parts, as well as motors for many other kits, such as the MK Ultra and the Open RC F1, and several of the 3D sets projects as well. Small parts management. I had a problem finding something that would handle all the small parts that I had, so I created my own sort of parts management system here. If you're not interested or don't need a parts management system, you can skip ahead to the next chapter. This just sort of shows what I've created, and you can download these. These are available on printables.com. They're about 30mm in size. They have labeling, which I find useful. The top number indicates how long the part is, and the bottom number indicates basically its diameter. So a 3 in the bottom would be M3, 12 would be 12mm. And you can keep it, you can keep other things in here. I've got different boxes with a little advanced or longer labeling for bearings that I'm using here. And these also stack on top of each other, so you can just bring out the parts you want. These plates are both for the top and bottom, which have holes in them. The bottom plates have little feet which go in, and when you stack them, the feet will go in the holes so that they won't slide sort of side to side. Very easy to stack them. Once you stack them all together, you can bind them. I used a very simple system to bind them, just simply a thick elastic. The parts are pretty well contained here, so they're pretty portable. You can shake them and none of the parts will come out of their bins. So it may be something you're interested in. It's available on printables.com if you want to print something like that. And I color code those as well. My M2 are one color, my M3 are another, and so on. Post-processing, I found I drilled a lot of holes out a little bit. The designer needs to make the holes a little small so it works on everyone's printers. If you have a part that needs to slide, then you might need to drill it out. And here are some examples here where you have a small gear. This is in the differential. You have a 2mm pin that goes in the middle. So these were drilled out with a 2mm bit. With polycarbonate, these are polycarbonate, the white here, these holes will shrink even more. And one of the problems in drilling out the hole is to make sure that you're drilling it out so that it's straight and the part doesn't wobble as it turns on its axis. This is a pinion gear And I had a problem drilling this out because the motor has a shaft of 3.175 millimeter. And I said, where am I going to find a drill like that? So I tried a 3 millimeter drill, and that didn't work in polycarbonate. It's hard as nails. And then I realized that's an 1/8 inch shaft, so I went and grabbed an 1/8 inch bit and drilled that out, and it went out fine. You've got to make sure you don't drill some holes out. These parts are designed to have screws screw into them. This is a grub screw, so you don't want to drill those out. You want those to be smaller so that this cell threads into it, just like in this shaft here. The electronics I selected, I found that Banggood had a pretty good deal on a motor and electronic speed control, so I bought this pair for about $50. Designed for a 2 or 3 cell lithium polymer battery. It was only about $50. The battery I chose was a shorty. One consideration, or I guess concern I might have, I don't have the battery in yet, is that it's 96 millimeters wide. It looks like the chassis is only 95, so it might be a bit of an issue. I may need to grind a little off the case here. This servo I used is standard. We'll see. I think that a standard servo fits in there, and that was only about $20. I already had a Dumbo RC, fairly cheap a remote, and that comes with a receiver, an X6 FG, G for gyro. That was only $50. So the total was only about $158, and that included all tax and shipping, so it wasn't too bad. So the first thing we'll look at here is the steering and assembling the steering system. This is a top view of it, and this is a bottom view. These pins will hook into mechanisms that we'll see later that will complete the steering and connect to the different rods that go to the wheels. So this is the basic chassis here. This was printed in PLA Pro, a little tougher version of PLA. And this shows I have the belt drive actually assembled, but I don't have the belt yet, so I'll show that in a future video. This is the speed controller. And the problem with this cross member is that it interferes with the speed controls you'll see. And this is for the airfoil at the end. This is the mount for that. So you'll see as this goes over, there's a little tab up here which is designed to hold the little switch for the speed controller, but it goes right over my fan. So I had to remove that. So I took the STL file, brought it into Fusion 360, and I modified it. It wasn't too difficult to put something that was a little different, that was especially for my speed controller. Now you don't really need to do this. You could just cut off that tab. You don't really need the switch. I don't often use it on my speed controllers. This is where those two tabs are where the steering's going to go, so we'll show how that gets installed. This is just showing the electronics around it. So these are the 3 parts. There are bearings that go in there. You can see these are the 3x7 by 3 millimeter bearings. You'll need some M2 10 millimeter screws and M3 12 millimeter screw. So we'll grab our bearings. I think we need 8 bearings. And there's 2 bearings that go in this piece. There's a top and a bottom. You need to make sure which is the top. This is the flat part here. And you may have to coerce it a little. This is where you want to make sure that your printer's been somewhat calibrated. On the bottom, you'll put a very tiny spacer. This is quite a thin little spacer that will go in and you'll put a bearing in the bottom. Sometimes they snap in easily, depends on the size of your hole. Sometimes you need to be persuaded. The balls here will mount on 3 places, and they'll mount with a M2 screw. So I'm drilling out these 6 holes with a 2mm bit, just so the M2 screw will slide through those and will thread into the ball. Now you're going to mount the ball right in the middle hole, but there is some adjustment if you find your steering needs some adjustment. Hard to see when you're doing this under a camera. So you'll tighten that up. You have 2 balls on each end there. There's one more ball that will go on the L-shaped arm as well. And so we'll drill out that hole. Be careful you don't drill out something that needs to be threaded into, or you'll end up reprinting them apart. I had to watch a few other videos to see exactly how this goes together, but the M3 12 millimeter long screw goes through the double bearings and it threads into the 2 different arms. One's a straight arm, one's an L arm. And you want it snug, but you want it to be able to move fairly easily. You're going to add another screw, 12 millimeter screw for the other arm. Now each arm has 2 bearings as well, with a little longer spacer. So the spacer goes in between them. Put the bottom bearing in first and the top. Use the pliers if you want to make sure they're snug. And we'll put the other arm in. Same process. This time the hole was a little small. We'll mount the L-shaped arm to the main part. We've already installed the ball on the L-shaped arm at the end. Now we'll need to mount this in the chassis. Now we haven't drilled out these holes with a 3mm bit yet, so we'll do that. There's a hole in the middle, I haven't drilled that out. I'm not sure if that needs to be threaded into yet. So we want to make sure that the M3 screw can go through that without binding. So this will push through those holes and through the bearings and into the post, and will thread into the post. They're fairly long, so it took a little elbow grease to get those in there. And there's basically this part of the steering system. There's more to it, as we'll show in a future video. I also just wanted to show how the drivetrain relates to that, and the speed controller, and how the speed controller switch will just connect into the little plate that I made. So at this point, everything seems to fit okay. Once we get our battery and the belt, we'll make sure the electronics actually works. Now we'll look at the shock system here. I opted for as much 3D printed parts as possible, so I ordered the springs that were recommended in the bill of material, and they came fairly quickly. And the shocks are a fairly nice system here. They don't have any dampers in them, but certainly these shocks are going to be fine unless you're jumping and you really need that damping as you hit the ground. You'll notice there's some balls that go in with the shocks, and these are just going to snap in, as we'll see in the video. So we've installed the shock, the arm, and one wheel, so we'll talk a little bit about the wheels as well in this video. And you can see the shock system working with the wheels there. The wheels are two parts. They're a tire, which was made out of TPU 95, and the rim. With the shock, you'll notice the balls here. The shock can move on the balls. And there's also a little screw underneath that doesn't allow the arm to droop too much. So I've got two colors there. You don't need to do that. You can make your rim all white. You'll notice that the TPU is a little squishy, which it should be, however still very slippery on a hard surface. When you're making this, make sure you have very little infill. I only had 5% infill. Mostly it's just walls on the outside. And I had to use support for the rim. I used about 5 strips of support. The layer lines are going across. Otherwise, I didn't get a nice wall. This color was done by height. I just have a single extruder. I just did that to make it a little prettier. Now there's going to be a 4mm axle, so there's a 4mm bit there, and I just need to drill out the center piece there. That's just a support member for printing. And you'll be using a 35mm flathead M4 bolt as your axle. So you just want to make sure that can work in through there. So that was the front wheel, but we're putting the back wheels on, so we need to do the same thing for this second back wheel. See the various parts at the left for this installation. This is what it looks like, the shock looks like. It's got a support member on the outside. You just twist to remove that and you can throw it away. Now you may have a little brim left on the inside. You've got to remove the brim of the small plunger because that will impede traveling in through the housing on the other part. And once you take that off, you'll find there'll still be a little edge, so I use a deburring tool or a file like a nail file to remove the edge of the brim. I think here I'll use a deburring tool. Now it's simply a matter of adding the spring, and then you'll notice that there's a hole through the piston part of the shaft, and you're going to put a 12mm M3 grub screw in through there. And the grub screw is going to extend on both sides so that it locks in the piston so it doesn't come out. Very solid, nice little shock. And you'll notice though, when you put this together, very important, you want one of the balls to face one way and one of the balls to face the other for these rear shocks only. If you notice the shock that's installed, the ball is on, I'll say, the down side on the right hand side, it's on the up side on the left hand side. And if you don't do it right, you'll need to take out the grub screw, turn it around, put it back in. Here I'm just mounting the ball. I think the designer recommended to use a grub screw, but you don't need to. You can just use an 8mm M3. You're going to need to thread into the brown cross member and the ball. So the ball has to be held fairly close. And the reason for that, I didn't want to drill out the brown hole because if I install an oil shock here, I'll need to thread into the brown cross member piece. So I want that hole to still stay threadable. So I'm threading this into two parts at once. So that's fine. The other ball will go into the blue arm on the rear arm. And I'll use a 12mm screw to put the ball on this part only because it's thicker. 8 wasn't quite enough. Just make sure you put the ball so it's on the outside of the arm. Again, I'm not drilling either the ball or the arm out here. Now I haven't fully attached the support arm for the airfoil. There are two M3 20mm screws. I'm going to use my drill here. This is a little tough going. So I just start both the screws, use the drill to do most of the grunt work. You can buy these cordless drills, relatively inexpensive. I'm sure I paid less than $30 from Amazon for this drill. It's not designed to drill through concrete, but works really well for this type of work. And it works much better than the electric cordless precision screwdrivers, which don't have enough grunt for some of this work. So I usually get them close and I like to hand tighten them. It allows me not to make sure I don't over tighten into plastic and strip the thread. This went pretty deep so you could snug it up pretty well. Now there's I think it's a 40 millimeter M3 that mounts the arm in. There's a couple holes I'm going to drill out. I'm going to drill out the hole in the blue arm. So there's my M3 bit, or my 3 millimeter bit. And even after you drill it out, sometimes you'll find that it'll still be pretty snug. So I actually put the pin in the drill. And if you speed up the drill, this can help make that smooth and make the pin a little easier to insert. I also drill out the very first hole, but not the second hole. You want this pin to stay in there. You don't want this pin to come out. So I want some force to grab that pin on the inner wall. So the pin will go through the first one fairly easily. It'll then grab the arm. And then the inner wall is a little tighter, so you're going to need a screwdriver to sort of tap it through. And you should see the pin come out into the opening on the inner wall. Now there are grub screws, 5 millimeter M3 grub screws that also go in and help to secure each of those pins. I'm not sure how tight they could make it, but I don't think they'll come out. Now we'll install our bearings. These are 5 by 11 by 4 bearings into the rear arm. And there'll be a bearing in the inside, a bearing on the outside, and a spacer in between. The inside bearing here needs a little force to go down, and I just used the blade of a flat blade screwdriver that's fairly wide. Doubles as my paint can opener. So the inside bearing, the spacer, and then the outside bearing. Again, you use pliers to snug them together. The M4 35 millimeter axle will go through, and there's a hex nut that I thread on. You don't want this, you don't want to screw this out because you want that hex nut to grab the axle. As the axle turns, so does that. And there's holes for 2 5 millimeter grub screws, one at the top, one at the bottom. I just put these partially in. And you want those grub screws to be on the inside, and you're just going to thread that all the way through that M4. And then you're going to tighten up the grub screws. Don't over tighten these grub screws. It's easy to strip these grub screw plastic shaft. And then you simply insert the wheel. You're going to get an M4 nut to put on the outside. I think that's a 7 millimeter socket. That's just going to snug in, make sure it goes into the hex shape of the wheel. The wheel's a little wobbly, but that's not going to hurt it. It's not a powered wheel. Now we're going to mount our shock. They just snap on to the blue ball. I was a little worried maybe they will come off, but there's no way they'll come off, I don't think. Now there's a grub screw that I didn't put in yet, and it's a 12 millimeter grub screw. And it sets the limit that those arms can droop, and there's a 7 millimeter they recommend you start with. The designer recommends that you start with, so I'm making sure that comes out 7 millimeters. You can adjust that. And then you'll snug up the top of the shock, and away you go. So that's our third installment